That's it on the lighting. Let's go to the next rung up. Geothermal and heat pumps. And again, unlike solar and wind, renewable geothermal and heat pumps do not generate electricity, but they magnify and increase the efficiencies to where, in a way, you are creating electricity from efficiencies into thermodynamics that we won't get into here. All right, the one thing I want to mention, and this is why I could battle the heat pump people, because I spent 30 or 40 years designing heat exchangers for the marine industry, excuse me, not 30 or 40 years with that, but in the industry. Anyway, from all this, and the patents I had and all the research and knowing the ins and outs of them, the thing I realized is, here's the equations I use for the marine industry. Well, they were the same for geothermal. Instead of a marine engine, well, we had a McDonald's in Ohio that was geothermal, so I tested a lot of this stuff out and found out that the stuff was accurate. But the simple model of geothermal is a building instead of a boat, and geothermal, instead of a sea of water it's going through, it's an ocean of granite at 48 to 50 degrees, a sea of that. So everything was pretty much the same. And I actually did a documentary on geothermal in the McDonald's, and I still have all those film archives. But anyway, so here's why I could push back with the geothermal people, even though it scared them a lot. They would all take responsibility, but I'm there, okay, that's fine, I will. The sea of granite and so forth. So bottom line is, fortunately, I had a lot of years of research in handling a heat exchanger. So, and we're going to pass through this. It's just the granite is at 48, 49 degrees steady. So you pump your water in, dump the heat, dump the cold out, and we can discuss that later if people want. Efficiency Maine, when I came here in 2012, 13, and I'm pushing geothermal bit, they're saying, geothermal, it seems a little risky to us, and it's expensive, and we're leaning towards the heat pumps. I said, what do you know about geothermal? Just that it might be risky. And I said, am I missing something? So I decided, okay, I'm going to go out of state and take a course on geothermal, which is what I did down in New Hampshire. They allowed me to film the entire session. Then I broke it up and I've got it in my archives. And everything I expected was correct. And it just, energy efficiency people aren't necessarily energy efficient or knowledgeable on it. Anyway, so I know how all the calculations work, but I'm not going to worry about that here. We'll just zip through this.
So geothermal is you just
People might go back, people might like the explanation of how it works.
yeah.
Okay,
Yeah.
yeah, there's
Right there.
Okay, it doesn't have to be complicated.
Yeah.
okay. It's just, what happens is, let me back this up here. Okay, let's say it's early morning, it's 45 degrees outside. The cabin temperature is set to 68 to 70 degrees at 6 a.m. each morning. It'll pull water from 68 feet into the cabin. 3 gallons per ton, or 18 gallons of water per minute at 49 degrees is going into the cabin. And the geothermal system we have is a 6-ton, which means it can dump up to 72,000 BTUs of heat in there. The bottom line, it'll raise the water temperature maybe 7 or 8 degrees as it's excuse me.
You missed a step. So it brings in that water.
It goes into the geothermal system, which goes through a Freon system. It's like your refrigerator,
Okay.
where you open it up, it's cold air, but if you're barefooted, you feel the heat blowing on your feet. Think of it as a refrigerator, but with a geothermal system, you can reverse it. You want a certain temperature, you get to the reverse, you'll feel cold air coming at your feet because you want it hot up there. It can go either way, and that's how it works with a geothermal. And so in this case, it's 45, we want to pull heat out of the water. And we're gonna lower the water temperature 6 or 7 degrees as it's returned to the well. And so what happens is the 3 gallons per ton, 72,000, essentially the water, if you used all of it, all 72,000 BTUs, the water would drop 8 degrees. So it came in at 48 or 50, it's now down to 40. And so we return at 41, an 8-degree drop. And so we're returning it, but we return it way down towards the bottom, 660 feet down.
660 feet?
Yeah, for the encasing and so forth, I calculated, I wanted to take a minimum of an hour to work its way back up to the inlet. An hour with granite, millions or billions of tons of granite at 49 degrees. By the time it gets back up there, it's gonna be at the same temperature it started with. So that's essentially what goes on there. Now let's say it's minus 20 degrees out there. It doesn't matter, it's doing the same thing and it's the same ground so forth. Yes, Arthur?
Mike, did you have to tell the contractors or the engineers how deep to go with that return?
They have their standards.
Okay.
And their standards were for minus 1 degree. And I told them I wanted minus 20, and when I found out, you pay so much for the rig to come in.
Yeah.
To drill the well.
Yeah, and so much for the first 20 or 30 feet with the casing and so forth, and then so much more circular.
Right.
But there's a point in time, it's like $5 or $10 a foot.
Yeah.
Yeah.
You might as well.
Give me the extra footage.
Yeah.
Does it get warmer as you go down?
If you get down, probably
To the center of the
1,000. When you start going down 1,000, 2,000 feet, then it can start warming up.
Okay,
Yeah.
wow.
It's amazing, huh?
So,
So you just need one well for the whole house?
right.
No, you said you have two, one for,
Yeah, one's domestic.
for water.
One's for our
Oh.
drinking water. I mean,
Yeah,
if
no, so
we
water well
had,
and a heat.
if we had a
geothermal.
water well that was deep enough,
Right.
we could have used it, but
Oh,
our
interesting.
water well wasn't deep
Right.
enough.
Yeah, we had it checked
One for
out.
drinking water, one for.
Yeah.
Yeah.
So we had an
Although
extra well.
We've set it up now that if one well goes down, I can use a hose, connect to the
Yeah.
system.
Well, you can see we have the well that we drilled is out here by the turnaround in the driveway, and it has a hand pump on it. So if we lost power and we needed water, we could use that water.
Plus, when that well went down, we had Airbnb guests here, I spliced and diced the hose so I could connect between the geothermal and our spigot. We had tested the water, it's drinking water, so it's fine that way, and that helped us out of that by, so, some redundancy. So that's, and that's why geothermal, and this is 18 cents a kilowatt hour. Our cost of running geothermal, for this example, is 59 cents for the 6 tons per hour. Natural gas, if we had it here, would have been $1. Wood, $1.26. Heat pump, it's actually 2 or 3 times higher because with the colder temperatures, it's not as effective.
Right.
And there's a point in time where it may default to electric heating
Yeah.
using toasters. And there's your electric baseboard, so, and propane, which is what we were using.
We originally had propane.
And we still do. If we ever had a long power outage or something, we can run the stove with that, and eventually,
But we couldn't use it for heating anymore.
yes, the oven.
Well, I mean, we don't have
Caution
a,
against
we don't
that.
have a propane
No,
burner.
no.
Yeah.
She doesn't consider that heat.
Yeah,
Yeah,
yeah.
You always gotta have backups, though.
Yeah,
You know,
yeah.
hate it.
Yeah.
in Maine.
Yeah.
Yeah.
So our system would work even at -20, which is what we'd see a little later. So that's pretty much what's happening as the water goes down and then slowly builds back up temperature again. Now, if for some reason it got to -30 and we started to overload the geothermal system, what happens at a certain point in time, that 18 gallons per minute, some of it would be bypassed out to the land so that you're not taking freezing water back
Right.
in and freezing things up, and it will be more water mixed in. So there's that, although we've never had to use it here. And again, geothermal installation, in this presentation, these are all the video slides, and if on the PowerPoint people click them, that would be the experts talking. So there's the scenario on geothermal, and with geothermal, there's really three types. One, you bury pipe underground like this, and under the thermal line, so it's more than 6 feet deep. Another is just drilling vertically downward, and the other is you're tapping in some water and so forth, which is what we did. We tapped into some aquifers. We brag to people that here at the cabin, we feed our grass Poland spring water. The ground, this type is 300% efficient, so for every $1 in, you get $2 additional worth of energy. You gotta add the $1 to 2 to get the 300. That's 350, and this can be up to 500% efficient, which is what we have, and we're somewhere around 450% efficiency here. And so we'll get by that. And here again is, it's been 13 years since I did geothermal. I went online, I said, okay, let's see if they got some rules of engagement to estimate. And again, for this kind of footage in the zone and so forth, it would have been about 20 tons here. But they're not expecting an energy engineer to do all the investments we did on the earlier rooms.
Now, if you were in a warmer climate, would geothermal be less or more or the same equal? I mean, I'm assuming the ground is the same temperature.
The ground is a little warmer as you move further south.
South.